Previously, you have looked at ratios, and ratios are a comparison of two numbers. Today, I want to talk to you about proportions. And as I talk and share with you about proportions, what is a proportion? Well, a proportion I would define as a comparison of two ratios. And it's an equal comparison of two ratios at that. So let's say that we have a ratio. Let's go ahead and just look at something such as this, something that we know. 1/2 is equal to 4/8. This is a proportion. Both ratios are equal because we know 4/8 reduces to 1/2. Now, if we think about this, could I rewrite this equation so everything was still true? Well, the answer is yes. What if I flipped the 1/2 over and made it 2/1? It's called inverting it. And if I do that on the left side, what if I do that on the right side? Do I still have a true statement? Well, 2 divided by 1 is 2, and 8 divided by 4 is also 2. So that works. What if I were to do a little bit more rearranging? What if I were to take the 8 and the 1 and flip those or change places? So the 8 would go up top on the left side. The 1 goes on the bottom on the right side, and I'll leave everything be. Is 8 divided by 2 the same as 4 divided by 1? Yes, that's also true. What if I go back to my original proportion and I switch places with the 4 and the 2? So now I have 1/4 is equal to 2/8. Well, that's also true. I have to be careful when I write proportions to be consistent. But you see that there are many ways in which I can write equivalent ratios as well. Now, when we talk about proportions, there's a way that you can solve them. And it goes along this line. Let's say we have A over B is equal to C over D. Well, in a proportion, this A is the first term. The B is the second term. The C is the third term. And the D is the fourth term. Now, when we solve proportions, we can solve them by cross-multiplying, namely to take A times D and set that equal to B times C. Now, the A and the D, because they're the first and the last terms, they're actually called the extremes. And the B and the C put together are the means. And you may have heard, or you may at some point hear, that the means equal the extremes. So let's talk about how to solve proportions using this idea of the means equal the extremes, or basically cross-multiplying. Let's say that we have 3/5 is equal to 12/x. And I want to find the value of x. So what I'm going to do is I'm going to multiply the 3 and the x, and I'm going to put those on the left side. And then I'm going to go ahead and multiply the 12 and the 5 and put those on the right side, which is 60. Now to solve this, I'm going to divide both sides by 3. And 3 goes into 60 20 times, and I'm done. This is a way I can solve a proportion using cross products or cross multiplying. Now, I can also use my skills about fractions and reducing fractions and writing equivalent fractions to find x. Look at 3 and 12. What could I do to 3 to get 12 by multiplication? Well, if I took 3 times 4, that would equal 12. So whatever I do to the numerator, I'd have to do to the denominator. So 5 times 4 is 20. A little quicker way to get there. Now, that doesn't always work, but that is something that you need to watch for. Now, let's take a situation like 3 over x this time is equal to 7 over 5. Now, I can't multiply 3 times a whole number to get 7, so I am going to have to cross multiply on this one. So 3 times 5 is 15, and 7 times x is 7x. So you're solving a one-step equation. Now let's divide by 7. And we'll get a fraction, x is equal to 15 over 7. Now, why do we want to be able to do proportions? Well, they help us solve things that are around us in everyday life. Let's say that we are wanting to put some new flooring down in our home. And we go to the nearest home improvement store and we see that one box of flooring covers 30 square feet. And what we know was we do some measuring, and we have an area that we want to put flooring down in that's 700 square feet. And what I need to do is I need to figure out how many boxes of flooring do I need to buy. So I need to set this up as a proportion. So first of all, I have a couple ratios. I get a ratio out of this one. That one box is equal to 30 square feet. Now on the other side, I don't know how many boxes I need. So I'm going to put x across from 1. And so in the numerator, this is boxes on both sides. And I'm going to put 700 on the bottom on the right side. And that's to show square feet. So 30 square feet is across from 700 square feet. Now if I cross multiply this, 700 times 1 is going to give us 700. And 30 times x is 30x. Now, to solve this, I'll have to divide by 30. And so x will equal, let's see, those zeros would go away, and it would turn out to be 70 divided by 3, which, that's the reduced fraction. Now, that might not tell us a lot, so if I put that in a calculator, I get 23.3 repeating boxes is what's needed. So if I don't have anything that I'm wasting, I would need, because I can't buy 23.3 repeating boxes, I would need to go to the store and buy 24 boxes at minimum. I might need to buy a few extra for waste, but that's a topic for another time. So this is how we can use proportions. Proportions, a comparison of two ratios. We solve them by cross-multiplying, thinking about the means is equal to the extremes. And then think about the context of the problem. Is it something I need to round, or is it something that I need to be exact? If I'm working in the kitchen, I'm going to want an exact answer. But in a situation like the box one, that's something I want to think about rounding off, either higher or lower, in this case, higher, depending on the situation. Thanks for watching this video about proportions. We'll see you again.